Okay, so we're going to start talking about proofs. These are going to be time consuming, they're going to be frustrating, but I want you to just sit through it, work through it. If you put in the time and the effort to understand proofs, you're going to get these and they're going to be a piece of cake. Alright, it's going to take the time and effort though. So first off, let's go back. Let's think about how we would solve this in Algebra 1. Our first step every time is distribute. So we got 4x plus 20 minus 15 equals 7x plus 3x. Our next step, we're going to combine like terms. So we got 4x plus 5 equals 10x. Next step, I'm going to subtract 4x and then I'm going to divide to get x by itself. So what we actually did there, if you listen to how I was talking through it as I solved it, those are the steps that we're using in a proof. A proof is basically a justification of our steps. So how did I get from step 1 to step 2? I distributed. How did I get from step 2 in black to step 3 in red? I combined like terms. What we essentially did is, I'll write it right now, but we substituted, and you'll see that in a minute. How did I get from the step in red to the step in green? Well, I subtracted 4x. And how did I get from green to blue? I did division. So essentially what we did is we made a proof. Okay, so we have a bunch of different properties of equality. A bunch of these we've already seen. There's a couple new ones that we may need to look at. So distributive property is start with something in parentheses and distribute. You've seen that before. Reflexive property, think of reflexive like a mirror image of itself. So A equals B, or A equals A. It equals exactly the same thing. Another example, 4 equals 4. You also have symmetric property, which is symmetry, meaning flip it around. A equals B, B equals A. We're going to use that occasionally. We won't use that one nearly as much as the others. Transitive property is going to take some time to figure out. We're going to be spending a lot of time using transitive property. But we have 3 statements, and that's the important part. To recognize transitive as well as substitution, you usually have 3 statements. So transitive property, if A equals B and B equals C, then A equals C. See how these are in the middle here? What we essentially do is we get rid of that and we say A equals C. So we look at the 2 on the outside. And then 5 through 8 we've all seen before. Addition, A equals B, we add C to both sides. We're just adding something to both sides. Subtraction, we're just subtracting something from both sides. Multiplication, same idea. We multiply by the same thing, as well as on division. We're adding, subtracting, multiplying, or dividing. So we're changing both sides of the equation. The substitution one is I'm taking x and I'm placing it wherever I see a b. We'll spend more time working with that, but I want to show you right now so you have it, so you can see it. Take a minute, try all of these, see if you can answer all 9 of these and match them with the correct property from here. So you may want to take a minute, write down all the properties of equalities, write down all 9 of them, and see if you can match them correctly on this slide. Okay, so let's check our answers. We started with AB equals CD, and then we added EF to each side. Since we added something, it's addition. Measure of angle 1 equals the measure of angle 2, which means the measure of angle 2 equals the measure of angle 1. They flipped around, which means it's symmetry, so it's symmetric. EF is equal to EF. It's exactly the same thing on the left side and the right side. It's a reflection. Oops. Spelled half reflection and half reflexive. Reflexive and symmetric properties get mixed up all the time. Just be careful. Number 4, measure of angle 3 equals measure of angle 2, and measure of angle 2 equals measure of angle 4. As I'm reading this, I already recognize that there's 3 things. Since there's 3 things and it follows a chain, it's transitive property. Next one, GH equals JK. So 2GH equals 2JK. The 2's are new, and it's 2 times that. So it's multiplication. Next one, 3x equals 2, then x equals 2/3. How did I get from this statement to this one? Well, the 3 is gone, and I got there by dividing by 3. So that's going to be division. 4 times quantity, x minus 7. Once you see parentheses, you know it's distributive. (3x plus 4 equals 12) gives you 3x equals 8. What happened to the 4? It got subtracted to the other side, so that one's subtraction. And then the last one, 2x plus 4 minus 3 equals 8. Take a look at these two. Those 2 became a 1. Combining like terms, from here on out, whenever we write a proof, we're going to write that as substitution. Combining like terms is substitution because we're taking the 4 and the negative 3 and we're replacing it with a 1. We're not changing the actual equation, we are just substituting one piece of the equation. What I want you to do, go through, check and see which ones you got right. When we go to class the next time, I want you to bring up the ones that you didn't get right, and we're going to work on practicing these. So now let's take a look at proofs a little bit more in depth. We're going to look at conditional statements. Conditional statements are if-then statements. You'll hear me use both, conditional or if-then. If a statement, then another statement. Whatever comes first is always your hypothesis, and it's your given. So if P, then Q. Remember, whatever that first if something, that's your hypothesis or your given. The Q is always your conclusion, regardless of how it's worded. So let's take a look at this. We have if, this, then this. So this is my given, and this is my proof, or my conclusion. You're always going to start here, and your last line of your proof is your conclusion. Always remember, number your proof, keep it as organized as possible, and whenever we write a reason, why did I write that? Well, it was given to me, so I write given for that reason. Now I need to start working ahead. How can I get x to by itself? I'm going to start by multiplying both sides by 2. When I multiply both sides by 2, I'm left with 4x plus 6 equals 18. Now what process did I do to get from there to there? I multiplied.
Jill Johnson, please report to the athletic office. Jill Johnson, athletic office, please.
Step 3. How do I start simplifying this a little further? I'm going to subtract 6 from both sides. Now I'm writing the step in a different color because that's not our reason. That's not our statement. That's the work to get from statement to statement. My actual statement is 4x equals 12. How did I get to 4x equals 12? I subtracted 6. Number 4. Still got to get x by itself, so how do I get 4 out of there? I got to divide by 4, and I'm left with x equals 3. Now how did I get to x equals 3? It's the part in red. It was division. So as you're going through a proof, the part in red is not actually your statement, but I'm still going to write it because that's the process to get from one step to the other, and that process is what we write for our reason. Once you get to x equals 3, you're done. You've justified all your work in a proper proof. So let's try it again. If this, then this. Here's your given. Here's your conclusion. So you always start with your given. And your first reason is always because it was given to you. So when we look at what we should do first, I want to distribute. Now, I'm going to put a box around this because I want to distribute -2. Most common algebra mistake is we forget to carry a negative sign throughout parentheses. -8 and then -2 times -x is plus 2x. So I distributed. Step 3. When I look at it, I see on the left side I have two numbers. I'm going to combine like terms, and combining like terms, remember, is substitution. So 3 minus 8 is -5. For step 4, I'm going to combine these into one step. I'm going to subtract 2x from both sides. And I'm also going to subtract 11 from both sides. It's okay to combine them. If you wanted to break that into two steps, you absolutely can. But since they're both subtraction, I'm going to put them in one step. -5 minus 11 is -16. And 6 minus 2 leaves me with 4x. Now I need to divide because I want to get x by itself. And one of the good things about proofs is that they give you the answer. I got to -4. I should get to -4. It's telling you, if you start at the given, can you work out a way to get to the conclusion? So you always have the answer. So if you don't get to -4, double check your work. You did something wrong, but you're always given that answer to help yourself out. We have one last example. Try it on your own before I do it, and then we'll check our answer. All right, start with your given. I need to distribute. I'm going to, in one step, subtract 4 from both sides, as well as subtract x from both sides. So subtraction is my step. And I'm left with 3x equals 13 minus 4 is 9. Oops, I gotta move this. I got to step 2 by doing distribution. And I got to step 3 by doing subtraction. Step 4 then, I want to divide both sides by 3. I got there using division. So as we're working on proofs, anytime you have any trouble, you got to make sure you're asking a question, got to make sure you're getting the extra practice. Proofs can be done. You just have to follow through and keep working at them.